Good morning, on and all present here. I'm Nandini D, working as an assistant professor in SNS College of Technology at the Department of Computer Science and Technology. Today, we are going to see a video on the subject generative AI on the topic what is Bayesian interference. So, we are going to see what is Bayesian interference first. So, it is a way of making a statistical interference in which the statistician assigns a subjective probability distribution which is used to generate a data. So these subjective probabilities are called as prior distribution. So this Bayesian rule is very important and updatable for us. So we are going to see some basic of statistical interferences. So the main elements of statistical interference problems are we should observe the some data that we collect in a vector of x. Second, we should record that x and we should realize of a random vector x. So we do not know the probability distribution of x to generate a sample. We define a statistical model that is a set of probabilistic distribution that could have generated the data. So these parameters of the model were put in the element in a corresponding set of real vectors called parameters. We use the sample and the statistical model to make a statement about the unknown data generating the distribution. This is a Bayesian interference. So it is trying to know the parameter based on the data. Parameter is also a random variable known as Bayesian rule. So next one is an objective in this Bayesian rule is we should have a belief or model parameter used in a prior knowledge and observation data. It is used for uncertainty and support probabilistic decision making. It is used to predict the adapt as more data becomes available. So these are the things or the objective that have been induced in an Bayesian's inference. Again, the next one is a problem statement. The the real world of data and uncertainty or an incomplete a complete data has not been given anywhere in this statement. So we should learn how to predict the challenges that have been inbuilt in the machines or how it is automatically updated. So this Bayesian rule helps the model to handle an uncertainty of data with some prior knowledge and how we can create some new evidences. By using this, a generative model uses a probabilistic insight of generistic, realistic new data that gives a more information in a predictable way. So these statements have some Bayesian interference key components have been there. First one is a prior Bayesian interference key component. Second was a live load. Third one is a posterior. So first one we are going to see is a prior. So the data have been encoded with the help of an existing knowledge. Within the given knowledge or within the given data, it has been encoded. Second, information, either the information will be strong enough or it will be enough little knowledge. For example, before tossing a coin, you may be predict whether it is a fair or it is a loss. That means whether it is a head or it is a tail. It is one prediction. Next is the livelihood. It is used to measure how well a parameter explains the observed data or when it is comes from a statistical model. For example, what is a binomial and a normal interferences. For example, if we are predicting we are tossing a coin for 10 times, how many possibility of getting 7 heads in that 10 times. So this is one of the livelihood function which is denoted by probability of data bar delta. So this is number of heads it has been tossed. The last one is a posterior one. So this posterior one combines prior belief and observed data used for prediction, decision makings and uncertainty estimations. For example, what level it has been result has been tossed, how this distribution been explained to this. This one is these key interferences. So next we have some more key interferences. How we are handling with the help of prior knowledge, we are handling an uncertainty data. That means if the data is less amount or incomplete data also we can handle it. The data with limited data, with the noisy data, everything we should manage in this Bayesian interferences. Then full probability distribution, if we have a full data or complete data also, we should have that range of outcomes to which peak level it is going and to which down level it is reaching. With the all of this interference components have been uh, easily sorted out. Next is Bayesian inference. With the help of this prior, livelihood, and posterior, with the help of the formula, a coin toss problem has been explained clearly with the example. So, thank you so much for the video.